Okay, so we're going to be doing this class in Python, so we need to spend some time covering the basics of programming in Python. Now, in some separate lectures, I'll show you some basics of working around a development environment. We're going to suggest Jupyter Lab as the development environment for this class. But before we do that, why don't we cover just a little bit of basic Python programming. So whenever you talk about any programming language, you want to talk about their primitives, their basic types and structures that are the fundamental building blocks of the language. How can we represent things like numbers and strings and so on? So Python has a few basic types. And if you want to see what type of variable your variable is in, or your structure is in Python, you can type. And then print will print out anything. If you want to do the very first thing you should do in a programming language, just type print, quote, hello, space world, end quote, and then type print, and then it'll just print to the Python command line, which is often called the REPL, the read, evaluate, print loop. So just the command line is often called the REPL. It'll print hello world. So type in the REPL what is type 10, what is type 10.0, what is type 10 plus 0j, what is type quote 10, end quote, and what is type capital T true. And you'll get the following answers. Now, in just the way that Jupyter is rendering these slides for me, I have to type print every time, but if you're doing this at the REPL, you don't actually have to type print every time. And it's going to say that 10 is an integer, that 10.0 is a floating point number, 10 plus 0j is a complex number. So just to interject here, Python has automatic complex number arithmetic built in. The complex unit is labeled j instead of I. Okay, and then quote 10 end quote would be returned as a string, which is shortened down to str, and then true is a Boolean. So true is a reserved word in Python, but only with capital T lowercase ru. If it's capital T uppercase all ru, then that is not reserved. And I've seen people do some things because a different language that they use has all lowercase true as the reserved Boolean or all uppercase true as the reserved Boolean, to say something like capital true is capital T, capital R, capital U, capital E is equal to capital T, lowercase r, lowercase u, lowercase e. That they'll do that so that they can use the one that they're used to. And I think that's a very bad idea because it makes your code very not portable to other Python programmers. So just get used to the fact that it's capital T, lowercase r-u-e, and capital F, lowercase a-l-s-e, false, for the two Boolean values in Python, and just get used to doing that. And if you also program in a different language that uses a different convention, just get used to the different conventions in different places. So in addition to our primitives, we also have some more complex data structures. So the most basic data structure, the most, when I say complex, different from complex on the previous slide, complicated data structures. So the more advanced data structure that we might have, the first one we might think of is a list. That is square, that you make a list with just square brackets. So bracket 1, 2 creates a list containing the elements 1, 2. Lists are very general in Python. List can contain list. List can contain just about anything else. List can contain functions. So list is a very general structure in Python. A tuple is created using parentheses, and a set is created using curly braces. And we'll talk more about the differences between these later. So Python is to some extent dynamically typed. In other words, it will make type conversions as needed for you. But if you find yourself needing to convert a one type to another, you can just use the sort of obvious things. So float will turn the integer 10 into the floating point 10.000, etc. And then for many objects, they have a method. So for example, if I define a as the integer 10, A and then typing a period references methods associated with the object. So when I type A, I create an object, A equals 10, I create an object. When I type A period, that creates or that references the methods associated with that object, and there's a method associated with this object, underscore underscore float underscore underscore, and then just open and close parentheses. We'll use that method, and that will convert A from a integer into a floating point. So you can look in most good Python programming languages, when you type a variable and you type period, it'll show you all the methods associated with that variable. So in this case, both cases say class float. So let's go through some basic operations and type conversions. So basic operators, Python of course has plus, minus, multiply, divide. And the standard order of preferences, goes on. Exponent is double asterisk, and double forward slash is integer division. Parentheses is modulo. And then type conversions happen if they're obvious. If you do 10 plus 10.0, it's going to convert the 10 int into a floating point and do that. That conversion for you. So, and then just to remind you of the last two, 10.1 modulo 2 is going to be 5. In other words, that the integer division of 10, 2 goes into 10 5 times with integer division, and then 10 modulo 2 is 0.1 or floating point 0.1 there at the end, referencing that is the remainder dividing 10 by 2. So strings and booleans. So strings are really easy to work with in Python, and that's why maybe Python is one of the most popular languages for natural language processing. So in Python, addition becomes concatenation, which is really useful. And brackets can reference characters, though I always want to emphasize this. Python, for all of its counting, starts counting from 0. So if I were to create the word ds for bio, so word equals quote ds for bio end quote, and then I do word plus space is great end quote, then that creates a new structure that is the referencing what the string word is, its value, which is ds for bio, and then concatenating it with the phrase is great. And so you'll see there on what it prints out that it'll say ds for bio is great. Similarly, if I type word bracket 0, that's going to give me D because that's the first letter, and remembering that Python counts from 0, starting at 0. That's the first letter of ds for bio. And word -1, it's going to count that from the end. So it's going to start counting backwards. So O is the last letter. When I go -1, that will give me O. If I were to do -2, that would give me I. -3 would give me B, and so on. So Booleans, just like I mentioned before, the strings capital T ru and capital F als are reserved. And those are Python Boolean operators. Also, the bitwise logicals, pipe, and ampersand, and negation, which is a tilde. So if I were to say A equals 5 less than 4, that, what does that do? Well, the statement 5 is less than 4 is false, so that will make the comparison, test the comparison, return the value false, and we're setting it equal to a variable A. So now A takes the value false. Now if I were to set B equal to the expression 5 double equals 5, that is testing whether or not the value 5 is indeed equal to the value 5, which is of course true. So now the variable B is set to the value true. Now if I were to say A or B, that would be false or true. And or is an inclusive or, so that would be true. If I were to do A and B, that is an and of a false and a true statement, which is false. And then if I were to do not A, that would convert my A, which is false, into true. So Boolean operators work pretty similarly to how you expect Boolean operators to work in general in most languages. One caution I would say is that when we get to more advanced data science topics, we'll often want to do Boolean operators pointwise without actually having to loop over variables. And so in order to do that, we'll use things like the ampersand, the bitwise logicals, in order to do that in one statement. So these statements like or, and not written out are mostly used at the sort of primitive level, and then when you get into more advanced data science topics, you tend to use the bitwise logicals. Okay, let's talk about some advanced data structures. Python has some more advanced data structures that are built on its primitive types. The main ones are lists, which are just ordered collections of nearly anything, including other lists. Sets, which are like lists but only have unique elements. And tuples, which are also like lists, but they are not mutable, which means you cannot modify it. So a list, you can change the first element to something else. Once you create a tuple, that's it, that's the tuple. And then dictionaries are Python's version of a hash table, and those are named elements that you can reference by their name rather than by their position. So dictionaries are quite fast if you want to look up something relative to an index rather than relative to a key value rather than an array index. So let's talk about lists, which are our basic data type in Python. So here I create a list, dat 1, 4, 8, 10, which is just a basic list structure, but it doesn't necessarily have to be all numbers. It could be some numbers and some strings, or some numbers and other lists, or some numbers and some tuples, or whatever. So if I type dat 0, that grabs the 0th element of the list. If I type dat 2 to 4, 2:4, that's going to give me the first and the second element of the list. Now, I just want to spend a second on this because this can be a little confusing at first. Remember, Python counts from 0, so the first element is 0, the second element is 1, and the third element is 2. So I think I might have said it wrong before, but it's the third element is 2, and then it doesn't include the second index. It's not inclusive of the second index. So this is going the elements 3 to 4 in the array, in the list. So it's going from elements 3 to 4 in the list. So if you look at our list 1, 4, 8, 10, when I do that, it does elements 8, 10, and so if I had another element in the list 8, 10, let's say 11, it would still only print out 8, 10. Those are the only because those are the elements. So anyway, just remember the distinction between the fact that Python is counting from 0, right? And that second of all, the second index is non-inclusive. Okay, so you get really used to it. It seems kind of confusing at first, but you get really used to it quite quickly. When you do dat 2:, it's just going to do everything from array index 2 onward, which will be the third element onward. So in this case, this will also be 8, 10. But if there was a next element in the list, say 11, this would return 8, 10, 11, whereas the line before would still only record 8, 10. Any rate, so I go through some other list operators, such as the elements up to element 2, 2, and then adding to making a list of 2 lists there. So there I take a dat, which is a list, and then put comma dat, and then put that inside a list. Now what I have is a list of lists. So it's a list of 2 elements each element is itself a list. So you can see that here by looking at it. It is a bracket, then a bracketed list in item 1, and then a bracketed list in item 2. So if I wanted to grab the 8 from the second list element, that would be dat2, which is what I called my list of lists. The element 1 would then, because remember Python counts from 0, so that would be the second element of list. So that would be the second copy of 1, 4, 8, 10. That would be the second copy of it. And then the fact that I am grabbing element 2, that'll be the third element of the list. That's 1, 4, 8. The 8 is the third element of the list. So that returns number 8. A list, like I mentioned before, can contain mixed elements. In this case, I take my my list of lists and then append a string to it at the end. So now it is a list containing a list containing a list of lists, and then a string. And then list plus for list is just concatenation. So really convenient. Okay, so that's list. If you want to spend some time learning Python, the first thing you should do is learn lists well. Sets, I think, are a little maybe less important. Once you're first getting started with Python, later on they become more important. But if you have to spend time doing something, spend a lot of time learning list well, and then after that learn sets. So sets can be created with curly braces. They only have the unique values, and sets can, like lists, can have mixed data types. So I just go through some examples here. For example, I create a set A, B, C, C, and then it just reduces that second C because it only has unique types. Okay, tuples are like lists. They have most of the same list properties, but they're immutable. So here I create a list. List 1 is ABC. Tuple 1 is also ABC. And then I reset the first element of the list 1, which is a list, obviously is a list and is named a list, as the element AA. So that works just fine. And then I comment this line out here that says tuple 0 is AA. Now, why do I comment that line out? And I haven't mentioned yet, but this should be one of the first things you learn in Python, is that the comment character is a pound sign. And more on that in 1 second. But why did I comment that line out? Because if I don't, it gives me an error, right? Because tuples are immutable. So if I try to change the first element of a tuple, Python says, no, you can't do that. And so my document wouldn't compile if I tried to do that. So I commented it out, but try it, and you'll see in the REPL, Python throws an error saying you cannot change the first element of a tuple, because it's immutable. Now, why do we do that in Python? Why do we have immutable elements? Well, often when you're programming, you might want to set things as immutable just to make sure at some point later on you don't forget and change them. Or change elements of them. If you really want something to stay fixed, then setting it immutable forces that to happen. And you might think, well, that would never happen to me. But I can tell you, as you write longer and longer code, things get more and more complicated. And programming against yourself, what I mean by that is programming in a way that prevents when you come back to it 6 months later is really good strategy. So things like tuples are very useful for that. Oh, and then on the other thing on the comment character is that we cannot have we don't have a block commenting character in Python. What some people will do is they'll use triple single quotes to do that. I don't like doing that. I prefer to just comment each line with a pound sign. But there's a workaround for that in Python because if you do triple quotes, it's just kind of a line that doesn't return anything, so it doesn't really mess up your code at all. And so people will use that for comment characters for block comment characters in Python. But anyway, I don't like that. So at any rate, I have some weird minutia here, such as you can have a list of sets but not a set of lists. and you can have a list of tuples and a tuple of list. So I give some examples of that, just basically saying that maybe sets is a less general structure than list and tuples. Okay, now dictionaries are quite cool. And so dictionaries are Python's implementation of a hash table. So if you think about a physical dictionary, and you want to go to the definition of an ostrich, right? So you quickly flip to the O section of the dictionary, and then maybe you traverse the O section a little bit, but you're flipping around in big chunks. Imagine how slow it would be if you have to turn page by page, check, is there O on the, or is there an ostrich on this page? No. Go to this one, you know. So array indexing is in a sense referencing the specific location, and so you have to, you know, go to that location. If you don't know where something is, you might have, you know, it might be at the very end of the array. In the worst case scenarios, you got to go, you know, length of array checkings to find that element. Well, hash tables avoid that cleverly with hashing, but we won't really cover hashing in this class. But at any rate, what this means is we can create data structures where you can reference a key value and look at its reference a key and look at its value, and it'll reference it quite fast. So here I just create a simple dictionary. It contains a dictionary label A, a key value A, and a dictionary label or key value B, and then the value of 1 for the key A and the value of 2 for key B. So now I can look up in my dictionary, I can just directly reference element A and it returns 1. And so that is a very convenient data structure. Just to be clear, in Python, maybe something you're not used to, especially if you came from R, is you have mutable and immutable entities. And so mutable and immutable entities act differently. So lists are mutable. So let's look at this code and I'll describe what I'm trying to show you here. So X is the element 10, and I define Y as equal to X. If I were, and then let me append to X 20. And then let me print Y. So just look at the first, I think it's 4 lines there. So look at the first 4 lines. And what you can see is even though I appended 20 to X, when I print Y out, it's now 1020. So what happened there? The fundamental idea is that Y is not a copy of X. Y is like literally equal to X in that sense. And so when you change X, you change Y. And so I think something to get used to, or something maybe that's a little confusing at first in Python, is that there are these elements that behave like this, and that if you want a copy of them, you actually have to grab, you have to force a copy. So now, as of now, like it says in the comment, X is now 1020. We printed out Y, and that was true, but if you printed out X at that point, that would also be true. But let me add to the 0th element of X, let me add 11. So now X is 21, is 2120, and if I print Y, then I see that it is also 2120. Okay. So things like numbers and strings are immutable, so notice that changing Y does not change X in this example. So I go through this, the same example with a number, and I say X is equal to 10, Y equals X equals X plus 10, and then I print X and Y. Notice X is changed, so it's 20, but Y is not changed, so it's 10. So notice the distinction in the behavior between these primitive elements like numbers and strings, and these more complex elements like lists. And I think you know when you first get into Python, this is a little perplexing, but it's something you get over quite quickly. Okay, so that's some of the very basic elements of Python, and then now we'll have some code demonstrations to show you it in practice.